Good morning, my dear students. Welcome to my physics class. Our today's topic is mathematical problems. Let's start now. At first, remember the equation of motion, equation of falling body, and equation of projected body. V is equal to u plus at, v is equal to u plus gt, v is equal to u minus gt. S is equal to ut plus half at square. For falling body, h is equal to ut plus half gt square, and for projected body, h is equal to ut minus half gt square. V square is equal to u square plus twice s. V square is equal to u square plus 2gh for falling body, and for projected body, v square is equal to u square minus 2gh. Now our first problem is velocity of an object uniformly increased from 20 meter per second, and after 10 seconds it was 60 meter per second. Determine the acceleration. This is our problem. Here the given informations are velocity, initial velocity and final velocity, and time is 10 seconds. We have to determine the acceleration. Now solution. Here initial velocity u is equal to 20 meter per second, and final velocity, this is final velocity, v is equal to 60 meter per second, and time t is equal to 10 seconds. This is the time required to change this velocity. So what is the acceleration? Now we know a is equal to v minus u divided by t, or here v means final velocity 60 minus initial velocity u is equal to 20 divided by time t is equal to 10 seconds. This is equal to 4 meter per second square. Therefore, acceleration is equal to 4 meter per second square. Now our second problem is a car is moving at 54 km per hour speed, and acceleration of 4 meter per second square was applied on it for 5 seconds. Determine final velocity and how much distance would it pass when it was engaged in acceleration period. Our given informations are initial velocity 54 km per hour and acceleration 4 meter per second square, and this acceleration period is 5 seconds. We have to determine the final velocity and distance during this acceleration. Solution. Here initial velocity u is equal to 54 km per hour. We have to convert it into meter per second. 54 into 10 to the power 3, because 1 kilometer is equal to 1000 meter or 10 to the power 3 meter. So we have to multiply 54 by 10 to the power 3, and 1 hour means 3600 second. So we have to divide this 3600. So after calculation, it is 15 meter per second. That means 54 kilometer per hour means 15 meter per second, and time t is equal to 5 seconds. Acceleration is equal to 4 meter per second square. What is the final velocity? And s is equal to what? That means distance during the acceleration. We know velocity v is equal to u plus at, and u means 15 plus a4 into time 5 seconds, and after calculation it is 35 meter per second. So final velocity 35 meter per second. Now s is equal to ut plus half a t square. Distance s is equal to ut plus half a t square. So u means 15 time 5 plus half, a means 4, and time 5. So 5 square. This is equal to 15 to 5 75 plus, after calculation it 5 square 25, and 4 divided by 2, 25 into 2 50. So this is 125 meter. Our third problem is a moving car of velocity 36 km per hour is stopped by applying brake in 50 seconds. What is the acceleration of the car? How far will it travel during this time? So our given informations are initial velocity u is equal to 36 km per hour. Here initial velocity 36 km per hour. We have to convert it in meter per second. 36 into 10 to the power 3 divided by 3600, and after calculation it is 10 meter per second. And time t is equal to 50 seconds. That is, the car is stopped in 50 seconds. So time is 50 seconds. And when the car is stopped, then final velocity v is equal to 0. There is no velocity when the car is stopped. And acceleration a is equal to what? S is equal to what? We know a is equal to v minus u divided by t. That is, v is equal to 0 final velocity, and u is equal to 10. V minus u, that is 0 minus 10 divided by time 50 seconds. And after calculation it is minus 0.2 meter per second square. Therefore acceleration is negative. As the acceleration is negative, it is retardation. Negative acceleration is known as retardation. That is, velocity of the car is decreasing with time. Now s is equal to ut plus half a t square. U means 10 time 50 second plus half, a means minus 0.2 minus 0.2 into time square t square of 50 square. This is equal to 10 into 50 500, and after calculation this is 250. This is equal to 500 minus 250 is equal to 250 meter. This is the distance. Now our fourth problem is a train runs at 3 meter per second square uniform acceleration, and its initial velocity is 10 meter per second. When the train will cross 60 meter distance, then what will be its velocity? A train runs at 3 meter per second square uniform acceleration. Here uniform acceleration is 3 meter per second square, and initial velocity of the train is 10 meter per second, and when it will cross 60 meter distance, what will be its velocity? Here initial velocity is equal to 10 meter per second, acceleration is equal to 3 meter per second square. Here acceleration, uniform acceleration, and distance 60 meter. So s is equal to 60 meter. Velocity v is equal to what? We know v square is equal to u square plus twice a s, or u is equal to 10. So 10 square plus 2 into a means 3 into s, that means 60. And here 10 square 100, 2 into 3 into 60 is equal to 360. This is equal to 460. That means v square is equal to 460. Therefore v is equal to root over 60, and after calculation it is 21.45 meter per second. So the final velocity, that is velocity after 60 meter distance, is 21.45 meter per second. Our fifth problem, a stone is thrown upward direction at 9.8 meter per second velocity. That is, the stone is thrown vertically upward direction. What is the time required to reach the maximum height? We have to determine the time to reach the maximum height. Our given informations are u is equal to initial velocity 9.8 meter per second, and also we know acceleration due to gravity g is equal to 9.8 meter per second square. This is the standard value of acceleration due to gravity. time t is equal to what? When the stone reaches at maximum height, its final velocity v is equal to 0. We know when the object moves in upward direction, gradually its velocity will be decreased because acceleration due to gravity is negative when the object moves in upward direction. When the object freely falls, then its acceleration is positive because gravitational force always acts on the object in downward direction. Therefore, when the object moves in upward direction, its acceleration due to gravity will be negative. That means velocity will be decreased, and at a certain time its velocity will be 0. And when its velocity is 0, the object will not move in upward direction further. It will return back to the ground. So at maximum height, velocity v is equal to 0. And we know v is equal to u minus gt for projected body. If the object moves in upward direction, then v is equal to u minus gt. And at maximum height, v is equal to 0. So 0 is equal to initial velocity is equal to 9.8 minus gt. That means 9.8 into time t, or 9.8 into t is equal to 9.8. That is here minus 9.8 into t. That is 9.8 into t is equal to 9.8, or t is equal to 9.8 divided by 9.8 is equal to 1 second. So after 1 second, the stone will reach at the maximum height. A stone is thrown upward direction at 30 meter per second velocity. What is the maximum height traveled by it? We have to determine the maximum height traveled by this stone, and its initial velocity is equal to 30 meter per second. Here initial velocity is equal to 30 meter per second. Acceleration due to gravity g is equal to 9.8 meter per second square. H max is equal to what? That means maximum height is equal to what? When the stone reaches at maximum height, its final velocity v is equal to 0. Already we know it. And we know v square is equal to u square minus 2gh. For projected body, v square is equal to u square minus 2gh. Or 0 is equal to u square. That means 30 square minus 2 into 9.8 into h max. Here z is equal to 9.8. Or 2 into 9.8 into h max is equal to 30 square. Or h max, that is maximum height, is equal to 30 square divided by 2 into 9.8. And after calculation, it is h max is equal to 45.92 meter. That means maximum height reached by this stone is 45.92 meter. A stone is thrown upward direction at 19.6 meter per second velocity. How much time it will take to come back to the ground? We have to determine the total time. That is time after how much time it will return back to the ground. If the stone come back to the ground, the displacement of the stone will be 0. That means if the stone returns back to the ground, then its displacement is 0 because initial position and final position is same. When the stone return back to the ground, its initial position and final position is same, so displacement is 0. So h is equal to 0, u is equal to 19.6 meter per second initial velocity, acceleration due to gravity g is equal to 9.8 meter per second square. We have to determine the time capital T is equal to what? That means total time. After how much time it will return back to the ground. That is total time t is equal to what? We know s is equal to ut minus half g t square, or s is equal to 0 is equal to u means initial velocity 19.6 into total time t minus half g means 9.8 into t square, or 4.9 into t square is equal minus 19.6 into t is equal to 0, or here t is common. 4.9 into t minus 19.6 into t is equal to 0. As t not is equal to 0, that is total time is not is equal to 0, so 4.9 into t minus 19.6 is equal to 0, or t is equal to 19.6 divided by 4.9. This is 4 seconds. So after 4 seconds, the stone will return back to the ground. If the initial velocity is 19.6 meter per second, then after 4 seconds, the stone will return back to the ground.